Mediator is a popular open source implementation of the Mediator design pattern. It's often used with ASP.NET Core MVC applications as a way to help keep controllers from becoming too bloated. The Mediator pattern is one of the 23 object-oriented design patterns described by the so-called Gang of Four in their book Design Patterns, published in 1994. Its purpose is to provide a loosely coupled way for objects to interact with one another. Essentially, the mediator object acts as a go-between, carrying messages between calling objects and objects that implement the behavior in response to those calls, and then taking those responses back to the callers. Mediator defines certain interfaces, like iRequest of T and iRequest handler of tRequest tResponse, where tRequest must implement iRequest. So essentially, when you create a type that is an iRequest of some response, then you create a corresponding request handler that handles that type and the associated response. Now, when your app starts, Mediator uses reflection to scan the app's assemblies to find all of the types that implement these interfaces. The Mediator package also defines an iMediator type and implementation, which are also registered as services in program.cs. Any controller or services that use dependency injection can request an instance of this iMediator service. Using that instance, it can call send to send an instance of iRequest of T to Mediator, which in turn will find a handler for that type. It will then create the handler and invoke its handle method. Once that handle method has completed, it will return the response, which will be of type tResponse, as the result of the call to send. With this approach, the code that uses Mediator and calls send has no compile time dependency or knowledge of the code that will handle the request. Mediator has similar types and methods for notifications, which mostly behave similarly, except that they don't return a response, and they may have multiple handlers that respond to the notification. Let's talk for a moment about how most API action methods are structured. In most web APIs that deal with data, the basic working parts of any given endpoint that modifies that data is going to look something like what you see here. First, there's some incoming model, and that model should be validated. Fortunately, we get this for free if we're using the API controller attribute. Then that incoming model is mapped to a business or data model. Remember, we don't want to expose our business or data models as our API wire protocol format, and so there has to be some mapping somewhere between these two different types. Next, the actual work of the model occurs. Whatever changes are being made to the system, whatever methods end up being called, however the state has changed and then must be persisted, all of that happens here, and it might require some querying in addition to various update methods. Once the work is complete, the business model must be mapped back to some API model, assuming that something's being returned and we're not just returning a 204 no content. And finally, an appropriate result must be created and returned. Very few of these typical actions have to occur in the action method itself, and there are a few refactorings that you can make to improve this design by reducing how much code has to be in each one of your actions. Let's do some quick refactoring. First, we can remove the validation step, since API controller attribute has that covered for us. Next, we can create a service that takes in the DTO, does all the work, including the mapping, and returns back the response DTO, leaving very little in the method itself. There's not much left to do here that would shrink this further. The only option that you might consider would be to use some type of helper to produce that result. You can use my ardalis.result NuGet package to achieve this if you like, either as a helper method or as an attribute on the action method. Or you could use Mediator, and then you wouldn't even need to inject in this service into each and every controller. Instead, all you would need to inject is a Mediator instance. A nice benefit of this approach is that it's consistent. You don't have to inject a different service into every controller. An author service goes into the author controller, and an order service goes into the order controller. Instead, you can basically make every one of your action methods look like this, and every one of your controllers can just have a Mediator dependency. Now let's take a look at a quick demo showing what this sequence of refactorings looks like in real code. The original version is a typical action method like this create method. Here you can see that we're posting an author DTO, we're mapping that to an author domain type, we're adding that to the system using a repository call, we're mapping the result to another DTO, and then we're returning an action result. We can take most of that work and put it into a separate service. Then we can inject that service, which we have created an interface for called iAuthorService, into the constructor. From there, we can reference that service inside our action method and basically reduce the entire thing down to 2 lines of code. Now, if we want to use Mediator, we can, instead of injecting a service, we can inject in an iMediator type. Then, inside of the action method, we need to just create a command, and then we can send that command to Mediator before getting back the response and still returning back an action result. Now, we don't even have to specify Mediator in the constructor every time, because we could also set it up so that Mediator is just a property of a base class like this. In this example, I've created a base controller class called myBaseAPIController, which simply has a Mediator property on it. Then I configure this inside of program.cs to use AutoFac to do property injection on this base type. Inside you can see the code is unchanged. One optimization you can make if you're going to use Mediator with your controllers to handle your APIs is you don't actually have to create the command inside your action method, but instead you could rely on model binding for that. Now this does change the signature slightly, so you have to update things like how you're going to tell Swagger what type you're using. But after you've got that taken care of, and assuming that your command looks a lot like the thing that you're going to actually be passing around the API anyway, this can save you another line of code. So what we're going to do is we're going to take the create author command that you see on line 25 here, and we're just going to make that a parameter to the method. Now with just that small change, we've eliminated the need for the commented out line of code, and we've basically made it so we just have 1 line to call Mediator and 1 line to return a response. You'll find all the code that shows how to wire up Mediator inside of the sample code that goes with this course, or on the GitHub repo, which is at the URL shown here. Although Mediator provides a popular solution to the problem of bloated controllers, it does so by adding another layer of indirection and another set of files. What if we could bypass the controller part of the Mediator approach and just have requests route directly to the handlers without any need for mediation? That's what API Endpoints strives to do at a logical level while still building on top of ASP.NET Core MVC. You can get essentially the same benefits as the Mediator approach without the need for as much extra plumbing, redirection, and files by organizing your controllers as endpoints. The Ardalis API Endpoints NuGet package provides base classes and other helpers to achieve this. The Fluent Generic style base class lets you determine any combination of request and result types. The package introduces the Reaper pattern and promotes its use for APIs over the much older MVC or Model View Controller pattern. Reaper stands for Request, Endpoint, Result, or you might hear me sometimes say response. Using this approach, each endpoint in your API has a single corresponding endpoint file with a public handle or handle async method that is responsible for handling the request. This sounds a lot like a Mediator handler, and that's by design. For organizational purposes, typically the endpoint's specific request and result types are grouped with it in Visual Studio through the use of a naming convention. As you can see here, each endpoint's request and result types are typically grouped with it. This is achieved by prefixing the related type's file names with the name of the endpoint with which they belong. This organizational structure makes it much easier to locate the appropriate DTOs when working on an individual endpoint. Let's see how we can use API endpoints to implement a set of web APIs with the Reaper pattern. First, let's look at an endpoint that creates a new resource, in this case, an author. You can see that pretty much the entire endpoint appears on one screen. The only thing that's not shown is a single closing brace. Each endpoint inherits from endpoint base async for asynchronous endpoints and is able to specify with request as well as with a result. There are various options for both of these, including no request and no result. Inside the endpoint, you can see that we're doing essentially the same work that we would have done inside of the mediator handler for this type of an operation. We take in the request, we map it to our domain model, add it to persistence, and then map and create a result. Let's look at another example using an update. Notice that the update looks very similar. The only thing that's really different here is that now we are going to specify the ID as part of the route. We also need to include the route inside of the request because a typical put request is going to include the ID. Also, because of the signature that API endpoints use for the handle async method, there's typically only going to be one type for the request. So while you might normally include a separate ID parameter for the action method, here we're going to take that ID and include it with the update author command type. ASP.NET Core MVC does not support this type of model binding directly, so we're using the from route and body filter to achieve this. Here's the update author command that is being model bound. Notice that it includes the ID, which is being set from the route, and is required. However, it's also marked as JSON ignore in order to make it so that it does not appear inside of Swagger. This is just a personal choice to make this simpler, and so I don't have to specify as many items. As we've noted before, it's perfectly acceptable and sometimes even preferred to include the ID inside the body of put requests. You can see the effect of the JSON ignore attribute when we look at the Swagger documentation for this endpoint. Notice that it does specify that the ID will be pulled from the path or route, and also that the ID does not appear inside the request body schema. The key benefit of using a package like Fast Endpoints or the minimal-api.endpoint package is to allow you to organize your endpoints effectively as separate files within a project. Examples of using each of these packages are available in the demo files for the course.